Well, hello guys, here Mr. G with another video for the grade 12. This time we're going to be solving a question on organic reaction. I'm going to leave the question in the description below so you can answer the question before watching the video. And before we start answering the question, don't forget to subscribe for the channel and thumb up for the video. This question, it was question 4 done in the Eastern Cape province in 2023 in September. The question said the flow diagram below show how compound P can be converted to organic compounds Q and R. And you have compound B, and compound B, guys, is a haloalkane. So here, this one is a haloalkane. Alright, let's say that it's a haloalkane. You have reaction 1, which is going to an alcohol, and you have reaction 2, which is going to a compound Q plus NABR plus H2O. So let's go on to the question. The question says for reaction 1, write down the name of the type of substitution reaction. So they are telling you substitution. Indeed, you know that this is all the compound P is going to be single bond. Everything there is single bond, is a haloalkane. And alcohol is also a single bond. And you need to know if you go from single bond to single bond, that reaction is substitution. Now they're asking you what type of substitution is that. And this one is quite simple. The reaction from haloalkane to alcohol, substitution is called hydrolysis. Well, it's hydrolysis. I do have a very old video on this one. I will leave the link. Reaction, ask now for the IUPAC name of compound R. Remember, it's an alcohol. Now, for this reaction, I want you to remember, you do need strong base, and that strong base must be dilute. Okay? It must be a dilute strong base for this reaction to happen. For example, sodium hydroxide or potassium hydroxide, for example. So let's do the reaction real fast so you understand what is going on, and obviously write the name of the alcohol. Okay, so here we are. Now here, this is the structural formula of the compound that they gave us. Let me show you. That is the compound CH3CHBr, CH2CH2CH3. So CH3CHBr, CH2CH2CH3. And for this reaction, remember, you do have to add a strong base. I'm going to write any base, it doesn't really matter. I'm going to write NaOH, and this base, remember, because it's substitution, this base must be diluted. So let's write it down here. This is not needed, it's just for you to understand, okay? So what is going to happen here, guys, is substitution. The places of the Br and the OH are going to change. So in other words, this Br here will go and take the place of the OH, and the OH will go and take the place of the Br there. Okay, that is what is going to happen. So what we have here, we have everything the same. H there, C, and C, everything the same, but instead of the Br, we are going to have the OH. So here will be the OH, and therefore this one became an alcohol. All right, now what else? The other substance must be there. So this is plus the Na instead of OH. We are having here Br. Guys, this is the reaction. They don't ask for the reaction. They want the name of this alcohol, but now it will be easier to give the name of the alcohol. All this is a straightforward alcohol, so we don't have to stress too much. We are going to count the carbons starting from the N nearest to the functional group. In this case, it's 1, 2, 3, 4, and 5. So it's 5 carbon, and therefore is a pent. And because it's straightforward, it will be pentan. Pentan, because it's an alcohol, it ends in AN, 2, all. That is the name of the compound they want. Now, if you think you are going to be Confused, then you write the reaction. It didn't take that long. And guys, there is 2 marks for writing that name. All they want is the name. 1 mark for the hydrolysis and 1 mark for the name. Now, the second question. For reaction 2, write down now, reaction 2 is here. Write down 1 reaction condition other than heat. Alright, so now before we answer that one, let's identify the type of reaction. We have in a haloalkane, which is a single bond, we already spoke, and at the end we're going to have NABR and H2O. Look here, it's quite similar to this one. At the end we have the NABR. However, we have also water. So what is this going to be? This is going to be elimination. This is going to be elimination, and more specifically it's going to be dehydrohalogenation. Dehydrohalogenation, in which hydrohalogen will be gone away, hydrogen and halogens will go away from the reaction. What is the condition, which is one of the question here? What is the condition for dehydrohalogenation other than heat? So in this case we also need a strong base, guys, like in the previous one. We also need strong base, but this base must be concentrated. That must be concentrated. It's not just strong base, it must be concentrated strong base. And that one will give you the mark. That will give you the mark if you say concentrated strong base. Let's write it down here. If you say concentrated strong base, you'll get 1 mark. Okay? So that is all. The structural formula of compound Q. Now, compound Q is the major product and is the product that is coming from compound P. So let's do like we did in question 4.2.1. Let's do the reaction real fast here. So here is the reaction, and for this one we're also going to add NaOH, and I'm going to write here at the bottom concentrated. So you know that base is a concentrated strong base. Now, what is this? This is elimination. And remember, halogen and hydrogen will go away. So for sure, this halogen here will go away. But we have 2 hydrogens that could leave as well that compound, that could be eliminated. This hydrogen and this hydrogen. Now, the rules say that the hydrogen that is going to be taken away will be the hydrogen that is coming from the carbon with least number of hydrogen. So in this case, this one here is the hydrogen that will be eliminated. Okay, so the compound, and this one is for the major product, will be exactly the same. This is hydrogen, 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 but here you will have carbon with 1 hydrogen, you will have another carbon with 1 hydrogen because the hydrogen on top is gone, and we have carbon with another 2 hydrogens, and you have the final one with the 3 hydrogen. Everything is the same. But now these carbons here need another bond to have 4, so this is an alkene here. That is the one that they want you to draw. It doesn't matter if the hydrogens are below or on top, but remember this reaction also have, and they're giving you that one there, NABR plus H2O. So it's part of this one is NABR plus H2O. They don't ask you for this one, guys. All they ask you in this question is to write the structural formula for the product Q, which is the major product. This one here is product Q. The one they want is that one. That is the answer. I write the equation so you understand where it's coming from. Now, where are the marks here? Well, 1 mark for make sure it is an alkene, and the other mark for the rest of the structure. If the structure have a mistake somewhere, you lose that mark. So it's not very difficult to have this one. If you have double bond, it doesn't matter how the compound looks like, you will get at least 1 mark. It's quite simple. So we carry on. Now we're going to compound the next question. Compound R can be converted to compound Q. For the conversion of compound R to compound Q, write down the formula or name of the inorganic reagent needed. Okay, now we go here from compound R to P. So we're going from alcohol to haloalkanes. From alcohol to haloalkanes, you will have to add the hydrohalogen. So now we're going all the way back here. Now to do that, guys, what we need to add the halogen. All right, we need to add the halogen. So we are going to add hydrohalogen. So will be hydrogen and Br. That is what we must add. So the Br take back the place where it was at the beginning from the OH. Remember, we are moving all the way back. So let's quickly go back here and do that reaction in this space that we have here at the bottom. This one is question 1.5, 1.6. So both of them. Okay, so what do we have now? Now remember, we do have this compound, this alcohol there. So we are going to have that alcohol. Okay, we're starting with the alcohol this time. All right, this is the compound we have. This is the alcohol we have. So what are we going to do? We are going to add a hydrohalogen, the halogen that we want. In this case, it's Br. So it's not any halogen, it's the halogen you want. In this case, we want to form back this compound where there is a Br, so it must be hydrogen bromide. That is the one. And then the substitution will take place again. The substitution will take place. All is going to happen is that the Br will take the place of the OH and the OH will take the place of the Br there. So in fact, the first question said what inorganic compound you need. This is the inorganic compound we need, hydrogen bromide. So what do we have here at the end? We have in the same compound, but instead of a OH, we're going to have back the Br. Everything is hydrogen. There we go. And what is the other product we have now here? H2O plus H2O. So this one is the question. Now, what is the name of this type of reaction? Well, guys, I really don't have a name for this one. I don't see a name. So I will say alcohol to haloalkane. I'll give that because I don't see a name. I've been looking for names in books and I don't find it. If anybody have a name for this reaction, you can write it in the comment and it will be very, very appreciated. So that is the question there. That is the question, the first part of the question in terms of this reaction. Now, the next part of the question says a mixture of ethanoic acid and propan-1-ol is heated in the presence of concentrated sulphuric acid. Guys, this one is esterification. Nothing to say. We have the combination of a carboxylic acid and we have an alcohol. This one is esterification, is what is going on here. Let's write it down here. That is esterification. I don't even know what they're going to ask, but I know it's going to be esterification. Write down the name of the reaction taking place. There we go. It's esterification. And then you will get 1 mark for that. Second, give a reason why the reaction mixture is heated in water bath. Quite simple. The alcohol is flammable, guys. Alcohol is flammable, and there is the second mark. Write down the structural formula of the IUPAC name and IUPAC name of the product form. So for this one, the best option is to write the reaction. So what do we have here? We have CH3COOH and propan-1-ol. So let's quickly do here the whole reaction and it will help us much more. So this is question 4.2.3, and what we have here, we have CH3. There we go. COOH. Sorry. OH. Let's write it like this. And like this. There we go. That is the carboxylic acid. The alcohol we have a propan-1-ol, so it's CH3. I'm going to write the functional group in this first carbon on this side here. Maybe, maybe like this. There we go. This is the alcohol we have here. Now what is going to happen when they join? This here will be broken at this point, as well as this hydrogen will be broken at that point. This one will go away as H2O. Alright, so we are going to combine that reaction of those two compounds right there. Therefore, what do we have here? We have, let's make this one a little bit more. There we go. Maybe there. We have here C with the 3 hydrogen. There we go. We have the carbon with a double bond and the oxygen. We have in the O, this O here that you can see, and then we go to the other carbon that we have the carbon, and then is the rest as normal. And this one is the ester that we have formed in the reaction. And remember, there is also water, so I'm going to write the water here. It must be there. It's not part of the question. The question is only for the formula. So they want this formula here. This is what they want in the question. They want that one and the name. So when you give the name, always the part of the alcohol is coming first in the name. This alcohol was an alcohol with 3 carbons, so it was a propan 1-ol. So that one is the first part of the name. So in the name, always the alcohol first, guys, and this one is propanol. So it's propyl. It's going to be propyl ethanoic. There is a link on this video I'm going to leave so you can go and watch. That is the answer for this question. So the mark, there's 1 for the name because they're asking you to give the name. There's 2 marks for the name. 1 for saying propyl, 1 for saying ethanoic, and there is 1 mark for the whole structure. Here is for the functional group is here. Be careful with the functional group. This is the functional group and you will get 1 mark for that, but there is 1 mark for the whole structure. Correct, guys. This is the end of this question. It's a long question. This could be tricky. The reactions could be tricky. I hope it helped. Next time we're going to be solving rate of reaction. Don't miss that video. But thank you for watching. Thumb up. You can write messages. Remember, if anybody have a name for this reaction, I'll appreciate it. We can write it there. And then that's it. Thank you for watching. Subscribe for the channel. Thumb up. See you next time. Mr. G here.